We're going to work on one more question about the circles, because the circles and the lines, those were learned, you learned those in, I believe, Algebra 1 or Algebra 2. Now this is the pre-calculus class, so we're going to put all those informations together and try to solve this question, okay? Let's see, there is a circle. The circle looks like this. Center at 1, 1. Radius 5. Okay. And there's a line that passes through 2 points. Okay. One point is -2, -3. Another point is 0, 1. All right. If you want to graph this circle and graph this line, you're going to get something look like this. Okay. And what I'm asking is the length of this segment on the line, but inside the circle. You get this idea? Of course, this is just the illustration. It doesn't really mean that it will pass through at this position, or it might be the other way around, right? Okay, but anyway, doesn't matter. So we are going to solve this and use all the information you have learned earlier. Now let's work on this circle first. We have a center is 1, 1. We have radius 5, and we know the circle has this x minus h square plus y minus k square equals r squared. This is the form we call this is a center radius form. There's another one, right? X squared plus y squared plus ax plus by plus c equals 0, and this is so-called standard form of a circle. But anyway, I give you this because I give you the center and I give you the radius. So the equation of this circle will be x minus 1 squared plus y minus 1 squared, because here hk is this center, and that equals 5 squared. So this is the first equation. That's the equation of the circle. And what about the equation of the line? Because we have a point and a point, and that should be y minus y1 over x minus x1 equals y2 minus y1 x2 minus x1. This is the difference in y over the difference in x, or rise over run. That's the slope of this line. This is the form of that. So we're going to simplify this by plugging x1, y1, x2, y2. Those 2 points are given. Okay, so x1, y1 is -2, -3. So let me just write this: x1, y1, x2, y2. So make it a little easier for you. Now I'm going to plug this x1, y1, x2, y2 into this. So let's see what we get. We have a y minus -3 over x minus -2 equals y2 over y1. So that will be 1 minus -3, 1 minus -3 over 0 minus -2. All right, now that 1 minus -3, which is 1 plus +3, which is 4, and 0 minus -2, which is 2. So that's 2. All right, now keep going. I got a y plus 3 over x plus 2. See, I'm simplifying this part, right? And that equals 2. Therefore, I multiply by x plus 2 on both sides. So I get a y plus 3 equals 2 times x plus 2, which means y plus 3 equals 2x plus 4. Therefore, y equals 2x. I move this 3 to the other side, or I subtract 3 from both sides. 4 minus 3, which is 1. So I have this. That's my second equation. See, I have one equation, I have another equation. So I'm going to solve this system of equations: x minus 1 squared plus y minus 1 squared equals 25. Okay, I write 5 squares 25. And then this one I get a 2, y equals 2x plus 1. So what I'm doing is I put this circle and I put this line into one system of equation. After I solve it, when I get this x and y, that will be the coordinate of the point that stay on both the line and the circle. Make sense? All right, when you solve this system of equations, this is what we learned in pre-calculus 1, or the system of equation part. Usually is in the chapter like a later 7, 8, or 9. But we should be able to do that because we can use the substitution method. I just put a y into this. I put the second equation, this y equals 2x plus 1. I plug that here. This is called a substitution method. Then I'm going to end up with an equation with only x, and then we can tell that's a quadratic equation. And of course, we know how to do that. All right, so let's do that. I plug this into here. I will have x minus 1 squared plus, instead of writing y, I'm going to write 2x plus 1. This is my y. And then minus y minus 1 squared equals 25. Okay? Okay, I'm going to go ahead and simplify. X minus 1 squared, either you use the formula or you use the FOIL method, which is like x minus 1 times x minus 1. Okay, and then you do first by first, outer, and then inner, and last. And at the end, you can just add a combined like terms. Or you use the formula a minus b squared, which is a squared minus 2ab plus b squared. So I don't know which method you like to use. It doesn't really matter to me, but you should get x squared minus 2x plus 1. If you don't know how to do that, you might want to pause here, and then you try to use the FOIL method and simplify that to see if you get that. Or you can use this a minus b. Here a is x and the b is 1. Okay, so that's the first part. And this 2x plus 1 minus 1, you only have 2x because plus 1 minus 1 canceled out. You have 2x, and then when you square, you get a 4x squared, isn't it? Because you're 2x squared, which is a 4x squared. Make sense? Okay, now that equals 25. So far, it's pretty nice, right? So I'm going to combine like terms. I get a 5x squared minus 2x minus 24. Because I have a positive 1, I bring this here, I minus 25 on both sides, I get negative 24 equals 0. Now this is not very obvious. If you want to simplify that, you can factor. If you want to solve this, you can use the factor method. I don't know how many of you still remember how to factor this quadratic expression, 5x minus 2x minus 24. So you're going to have x, and you have 5x, and then equals 0, something like this, right? So you're looking for two numbers here, and these two numbers multiply, you should get a negative 24, and this number times 1, and this number times 5, you should add up to negative 2. This is not very, very obvious. However, we have the quadratic formula x equals 2a negative b plus minus square root of b squared minus 4ac. You can use this method too, and I would prefer use this when I see this because it's not very obvious, right? You got to try all the possible combinations to factor this 24, and then you try all those ways, and I don't think it's very easy. So let me just use this. And for this quadratic expression here, I get my my a is a 5, my b is negative 2, which is the coefficient of the x term, and I have my c is negative 24. Therefore, my x equals 2a, which is 2 times 5, okay, negative b, which is negative 2, all right, then plus minus square root of, okay, so b squared, which is b squared, that is a 4, okay, and then minus 4 times A times C is negative 24. Okay, so I have a positive 2 on top plus minus the square root of, and the bottom I have a 10. 4 times 5, which is 20. 20 times 24 is a 480, and it's a positive because here's a negative, here's a negative. So I get a positive 480 plus 4, which is a 484. Okay, do you know 484? You take a square root, it should be 22. Okay, then I keep going. My x is 2 plus minus 22 over 10. If I take the positive, so my x1 is going to be 2 plus 22 over 10, which is 24 over 10, or I simplify this by cross out the factor of 2, so the bottom is 5, the top is 12. And my x2 is going to be 2 minus 22 over 10, so that's negative 20 over 10, so that's negative 2. So very good, I get x1, I get x2. And then how do I find the y1, y2? And do you remember that you have this? Okay, so you have this two equation. You can plug into either one. I would prefer to put in this one, y equals 2x plus 1. So I remember that y equals 2x plus 1. So when x1 equals 12 over 5, my y1 will be twice of that plus 1, so it's 24 over 5 plus 1, and I write this 1 as 5 over 5, like least common denominator, so I get a 29 over 5. So I have a 1 point, 12 over 5, 29 over 5. Good, right? Okay, and my x2 is negative 2. And of course, well, if you remember, I guess you don't. If you remember, I said the line passed through this negative 2, negative 3. So when x equals negative 2, you can get that y2 should be negative 3 right away. But if you don't remember, that is totally fine. You can also plug this into this. So I get 2 times negative 2 plus 1, which is negative 3. So there's another point, negative 2, negative 3. This point, those 2 points are the intersect point of, they stay both on the line and the circle. And then next we need to find the segment, the length of the segment inside the circle on the line. So it's going to be the difference between these two, or the distance between these two. Now, quick review. The distance is, okay, y2 minus y1 square plus x2 minus x1 square. All right, so that's my x1, y1, x2, y2. So that's going to be, my y2 is negative 3 minus 29 over 5 square plus negative 2 minus 12 over 5 square. Okay, like that. And I ask you to give me the distance in decimal form and keep like a, I think I would prefer like a 2, maybe 2. Let's keep 2 decimal points. Okay, so 29 over 5, which is 5.8, and 12 over 5, which is 2.4. So I have negative 3, negative 5.8 square plus negative 2, negative 2.4 square. That is negative 8.8 square plus negative 4.4 square. Now, of course, I'm not going to let you do this by hand, and you can use your calculator. All right, now your calculator, I think I just use a very, very simple calculator. Okay, so do this one. 8.8. negative 8.8 squared is the same as positive 8.8 squared. So I do 8.8 square. When you do square, the trick on some calculator, you just need to hit multiply and then equal, which means it's square. So 77.44, 77.44. Okay, and this negative, I can just ignore that. So 4.4 square is 19.36. I add them up, 19.36 plus 77.44, I got a 96.8. So that's going to be the square root of 96.8. So let's take the square root of it. I got a, if I keep 2 decimal places, I got a 9.84. So 9.84, that's my answer. All right, now I want to show you what it looks like on this. Okay, let me just use different color. Different color, blue, red, and everything. Okay, so the first one is the circle, and remember the circle has 1 as the center, and a 5 is the radius. So 1, 2, 3, 4, 5 goes here. 2, 3, 4, 5 here. 1, 2, 3, 4, 5. Of course, I cannot do this graph very well just by hand. I try my best. Okay, so it's not bad. Okay, it's not a very pretty circle, but that's it. Okay, and there is another one. Is -2, -3. Another one. Now let me just change the color. I use the blue. Okay, it passes through 2 points, right? One is -2, -3, and the other one is 0, 1, which is this. So I'm going to use this to connect that, and then draw the line, the blue line. All right, now I'm looking for the length of this segment. All right. So see, this point is -2, -3. Okay, and this point, as we solved, is what is a is 2.4, 5.8. Get that? So this distance right now is 9.84, roughly 9.84. That's the illustration of this. That's a graph. If you really want to graph that, you can see. And now this question looks like very complicated at the very beginning. And let me just get that. Okay, that's the first page that I give you some information about a circle. So basically, I need to use the information I give you to come up with the equation of that circle. And also, I give you some information about the line, and then based on what you have learned to get the equation of the line. Then you put them into one system to solve it, to get the solution, and that solution tells you the coordinate of the points that stay on both the line and the circle. And we did that, and you look, we did a lot of things, and then we got the quadratic equation to solve it. See, there's so many things you have to know, right? And then we get x1, x2, and then we plug that back into the linear equation to get a y1, y2. So we get the coordinates of these 2 points. And then you use that, the distance formula, to find the distance, which is the length of the segment of that, the length of the segment inside the circle, but on the line, and we got 9.84. This is, I believe this is pretty hard, right? You can tell that it asks you to remember all the things that we have learned. All right, good luck.